Okay, here is warm-up 5.2. The three angles of a triangle have those three expressions, and we're going to solve for x. So I'm going to draw a little picture here. It's just a generic triangle, and I'll put x, 2x plus 4, and 2x minus 9, just to get a visualization. Okay. So the triangle angle sum theorem says that the three angles of any triangle are going to add up to 180. So now I can say, okay, x plus 2x plus 4 plus 2x minus 9 is going to equal 180. Okay. And then we can solve this. So I'm going to start combining like terms. So I'll combine the x terms. I've got x plus 2x, that would be 5x. And then I can combine the 4 and the negative 9 into negative 5. Okay. Now I'm going to isolate the x. So I'm going to add 5 to both sides. And I've got 5x equals 185. And then last thing is to divide by 5, and now x equals 37. Okay, so there's my x value. All right, so now I want to classify this triangle by its angles. I need to know the measure of the angles. I've got x, so now I can figure out those angles. So let's see. X equals 37. That's the top angle, right? Then the 2x plus 4, well, I can substitute in, I'm looking at this angle, 2 times 37 plus 4. So 2 times 37 is 74. Okay, so that next angle then is 78. So here I'll put these in the picture up here. This angle is 37 degrees. This angle is going to be 78 degrees. And then the 2x minus 9. X again is 37. So I've got 74 minus 9. And that's going to be 65. Okay, so that means that this angle is 65 degrees. So now looking at this, so what I'm looking for, it's definitely not equilateral. All the angles aren't congruent, or equiangular, I should say. So I'm looking now to see if is it a right triangle, and it's not. There's no 90-degree angle. So I'm looking then for either obtuse or acute. So if I can find any obtuse angles, then it's going to be obtuse. But none of these are obtuse. All three of those angles are acute, and that means that this is an acute triangle. Okay. All right. Next up. So, hey, I've got a triangle here, so you could write an equation to say all three of these angles add up to 180, but the problem there is that I've got two variables, and so I wouldn't be able to solve for x and y if I did that. Luckily, I have this 130 out there because that's going to help me get started on the triangle. And there's two different things you could do. One thing you could do is you could look at these two. They're going to add up to 180, and you could find x that way. And once you have x, then we can get working on this triangle in there. That would work great. Great. Another thing you can do, this is a this is an exterior angle. It's on the outside of the triangle. It's created by extending one of the sides. And if you look at the angles on the inside, the 2x angle is close to that one, but the other two angles are farther away from the 130. So these are called remote interior angles. And there's the remote interior angle sum theorem tells me that these two remote interior angles are going to, the sum of these is going to be equal to 130. So I can also say 54 plus 4y is going to equal 130. Okay. So I'm using this method because that's kind of the new method from this section. But if you did it the other way, that works too. Okay, so I've got 4y equals 76 then. And then I'll divide by 4. And I've got 19 for y. Okay, so solving for x and y, hey, I've got the y there. All right. And again, with the x, there's two different ways you can get the x, because now you could find this angle and say all three angles add up to 180, or we can use this linear pair. Together those form a straight line, so I can say 130 plus 2x is going to equal 180. Well, that seemed a little quicker to me, so I went that route. So then 2x is going to equal 50, and x is going to equal 25 after I divide by 2. Okay? All right, last problem. Classify this triangle by its angles. So looking at all three of these angles, there's no right angle. There are some acute angles, these two. These two are less than 90, but this one is more than 90. This one is obtuse, and just having one obtuse angle is going to make this an obtuse triangle. Okay, and now by the sides, I'm looking for things like equilateral, isosceles, or scalene. And equilateral, all three sides are congruent. That's not the case. Isosceles, two sides are congruent. That's not the case either. When all three sides are different lengths, that is going to be a scalene triangle. So this is an obtuse scalene triangle. Okay, and that's the end of the warm-up, and I'll see you next time.